before we start soldering, we need to make sure that the components are clean. Now this resistor leg has got oxidization, and we need to remove that. And the simplest way to remove that is using a pencil rubber. If it's a bit worse than that, then we can use a wire brush, or if it's really bad, we can use some solvent cleaner. We need to protect the component from things such as heat. Now this is a heat clamp, and we can put this heat clamp on the component, and that will take away the heat. When we're soldering here, it will take away the heat and it'll stop it getting to the component, and it will protect this component. We also need to protect the component from electrostatic damage. So we produce high voltage when we're walking around, and that electrostatic voltage could damage sensitive equipment. And so we need to use a wristband, an anti-static wristband. Connect that around our wrist, and then the other end is connected to an earthed point. So we generally use the bottom of the power supply there. We need to protect the components from mechanical damage. So before you put the component into the board, you need to bend at 90 degrees with a pair of pliers. If this is the distance of the diameter there, D, we need at least 2 diameters there. And you can see this one here is about 5 diameters. So it's a good distance away from the resistor. This one is a bad example, so we've bent it too close, and you can already see mechanical damage around here. Always wear eyeglasses when you're soldering to stop solder getting into your eye, solder splashes. Make sure you've got adequate ventilation, and make sure you've got adequate clothing. Covered footwear in the workshops. We need to make sure that the workbench is clear, and you've got plenty of space to work. Now this is a decent solder join. If we look at the join down here, we can see the component leg coming through there, and we see the solder around it. It looks like a sort of volcano shape. That's the kind of soldering that you're looking for. This is not what you're looking for. So this is a bad example here. We've got short circuits across the tracks, so we shouldn't see any solder across the tracks there. We've got poor soldering joints here. Probably the only decent soldering joint on here is this one. So how do we ensure that we get nice joins like this and not like this? First thing is that we need the correct iron temperature. Now the solder will melt at about 188, but it won't flow very well. We need to get the temperature up into this range, 250 to 270. If it's too low or too high, then we'll get what's called a dry joint. The solder won't flow, and we won't get that nice joint. If it's too high, the temperature's too high, then the flux inside the solder will burn, and then the flux allows the solder to melt and to flow evenly. And with no flux, we don't get that nice flow. So we want the temperature set on our soldering irons around about this place here, and that will give us enough temperature to make that solder flow. We need to use the correct tip, and we use generally the conical type tip. If we were to use a chisel tip on a small electronics board, then it's going to give us short circuits. That's going to melt the solder across the tracks. It's going to be far too big, and these ones are going to be the wrong shape. Here's the one that we're going to use. Size of the solder is important. You can see this is 16 gauge. The 16 gauge is quite big solder, so we wouldn't use this for electronics type work. We would use this smaller solder here, which is probably a 21 or a 22 gauge. If we use too big a solder, then if we've got too much on there, then we could get short circuit to the next track. This is the ideal shape that we want. There's our tracks, and there's our volcano shape there. Too little solder, and this could break off quite easily, so we could get a dry join, a loose join again. So we want the correct amount of solder, we want the correct temperature, and we want the correct tip to get this type of solder shape.